Let's summarize this particular chapter, integrals. Now, you know that this is one of the biggest chapters and probably the most important and weighted topic of this year, right? Now, when we started with integration, first thing is you need to understand what is integration, correct? It's basically summing up of things. Now, moving on, basically when you find or when you solve integration, you're actually doing the antiderivative of a function, isn't it? So you learned about the basic definition of integration, stating integral of f of x dx is equal to capital F of x plus c, right? Where c is the integration constant. This is the basic definition of an integral, or you can also call it as antiderivative, correct? Now, after that, we discussed about methods of solving different type of integration problems. The first method is a method of substitution, correct? Now, in this particular method, what we do, we take the variable and we are going to substitute it by another variable, correct? And as you change, for example, as you change x to t, dx also becomes dt, right? So this was the basic type of substitution method of problems. Now, within this substitution, you have different forms, isn't it? Like you have trigonometric substitution, right? Once you have the trigonometric substitution, you are taking some variable x in terms of some other trigonometric function like sine, tan square, or cos theta, whatever it can be, right? So this is the substitution, but using the trigonometric functions. Next, within that itself, you have algebraic substitution also, isn't it? So we have algebraic and also trigonometric substitution. Then after this, what do we have? Then you're going to understand special types of functions, isn't it? Like see this one. So 1 by x square plus a square, x square minus a square, all these functions, isn't it? We derive this by using substitution method, isn't it? And that too trigonometric substitution, right? So these are certain special functions what you have. Now, after this, the next part is we moved on to the second way of solving integration problems, that is integration by partial fraction method. Partial fraction, what were we doing? You used to have a function in numerator and denominator. You can say p of x divided by f of x or f of x by p. You can take it however you. Now for the partial fraction method, to use partial fraction method, what you need to have is that the degree of the numerator should be less than the degree of the denominator. It can be equal to also, where you can do just long division and get it done. But you have to have the degree of numerator lesser than the degree of the denominator. Correct? Since you have this particular combination, what were we doing? You used to have different cases, correct? Now, what if you have in the denominator, of course, what if you have something where you can split, in the sense, what if it can be a factorized polynomial? Then we use a by the first one plus b by this one plus c by this one, correct? So this is the first type of partial fraction problems. Second type, what if you have repetition? What if you have something like x minus 1 whole cube or x plus 1 whole to the power of 4, something like this? Then what do we do? So we have a by that plus b by that plus c by that based on the power of that particular denominator, right? The next type of partial fraction, you used to have irreducible polynomial in the denominator. Something like x square plus 1 or x square minus 5, something like this. Or sorry, x square plus 5, something like this basically. Then remember, this is the form, correct? You can have ax plus b divided by that plus c by that, whatever it is. So basically, what we have is different forms of partial fraction method. Now, in every partial fraction method, what we used to do, we used to split it and then integrate it separately. Then finally, you used to get the answer, correct? So this is the partial fraction method of solving integration sums. Now in this itself, you can have, something like px plus q by ax square plus bx plus c, or px plus q by root of ax square plus bx plus c. So you get to see the form. See here what you are going to have. All the different types you have, correct? This is another way. Again, this also comes under substitution. To be, more precise, you can say that it comes under substitution more than what we have for partial fractions. All right, this is the second type. The third type of solving, which is very, very important, integration by parts. Now, parts, what do we have? If you have two functions, and you're trying to integrate these two functions, then there is a formula and there is a precedence, correct? The formula, what you have, u into integral of v minus integral of u dash into integral of v dx, of course. This is the formula. And what is the rule, the precedence? We have to start from the inverse functions first. Remember, I laid inverse, log, algebraic, trigonometric, and exponential, correct? This is the precedence in which we are going to integrate the function, correct? Now, once we are done with the integration by parts, then we have these three special functions, correct? Now, remember in your board exam, they expect, suppose if they give you these kind of questions, they expect you to write step by step. And generally, the problems will be like find or integrate root of, say, a square plus x square, hence evaluate. Some question will be there. So basically, they are going to give you the function, they'll ask you to integrate, and using that, you have to derive another problem. This is how it's going to be. Okay. Then once we finish this, we are we have revised and also concluded what we had for indefinite integrals. Right. Then moving on to the definite integral part. Now, definite integral is what? Just you integrate, put the upper limit and lower limit. Like what you're seeing here, integral of f of x dx from a to b is f of b minus f of a. There is no constant or integration constant for a definite integral, right? Then as we move on, we started off by fundamental theorem of calculus, correct? Then area under the curve, because whenever we do definite integral, that gives us the area under the curve. Make sense? After that, then what did we do? We discussed about different properties of the definite integral, which are probably the most important ones. Okay, as you can see, these are one set of definite integral properties. Now we are seeing another set of definite integral properties, correct? So make sure you remember a couple of them which are very important, like the changing of variable, or if you have 0 to a, then f of a minus x, or if you have minus a to a, then what if the function is odd or even, then what's going to be the value? See, these are certain properties of definite integral, correct? Next, you had solving problems based on these properties, isn't it? Now, these are the things what you have in definite integrals and whatever you had studied in the couple of previous videos, right? So this summarizes the entire chapter of integral, that is part of indefinite and part of definite. So this concludes the chapter called integration.